Somewhere out there in the universe lies a monster so massive it could swallow entire star systems. Without a trace, I'm not talking about a science fiction villain. This is real. The largest black hole ever discovered is so huge, it makes our sun look like a single grain of sand on a cosmic beach. And today, we're diving straight into its dark heart. Buck up, because what you're about to hear will bend your mind. But here's the question. Just how big can a black hole really get? The answer will leave you speechless, because the biggest one we've ever found has a size that defies imagination. We're talking about something so enormous that it makes Jupiter look microscopic. First, let's talk basics. A black hole is formed when a massive star, at least 20 to 25 times the mass of our sun, reaches the end of its life and collapses under its own gravity in a catastrophic implosion. That happens in mere seconds. The core becomes so dense that not even light can escape its gravitational pull. Most stellar black holes are only a few times the mass of our sun. Big, sure, but nothing compared to the cosmic titan we're about to meet. But before we dive into our monster, let me give you some perspective on black hole sizes. There are different classes: stellar black holes, intermediate black holes, and supermassive black holes. Our galaxy's central black hole, Sagittarius A*, weighs in at about 4 million solar masses. That's already mind-boggling, right? Well, hold onto your seats. Ton 618, the heavyweight champion of the universe, and quite possibly the most terrifying object we've ever discovered. This supermassive black hole lurks about 10.37 billion light-years away in the constellation Canes Venatici, and scientists estimate its mass at, get ready for this, 66 billion suns. Yes, billion, with a B. To put that in perspective, that's over 16,000 times more massive than our galaxy's central black hole. Now let's really put that in perspective, because numbers this big are almost impossible for our brains to process. If you replace the sun in our solar system with Ton 618, its event horizon, the point of no return where escape becomes impossible, would stretch an incredible 300 astronomical units from its center. That's roughly 195 billion kilometers, or about 121 billion miles. To give you an idea of scale, Pluto orbits our sun at about 40 astronomical units on average. This means Ton 618's event horizon would extend more than 32 times farther out than Pluto's orbit. Think about that for a moment. Our entire solar system, Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, Neptune, Pluto, and even the Kuiper belt would all fit inside this black hole's event horizon with room to spare. We're talking about a sphere of inescapable doom that could contain dozens of solar systems like ours. And here's the absolutely wild part. Ton 618 isn't just sitting there quietly in the darkness. It's an active quasar, which means it's actively feeding. And when I say feeding, I mean it's consuming matter at a rate that's almost incomprehensible, as gas, dust, entire stars, and planetary systems spiral into its gravitational jaws. They form what's called an accretion disk, a swirling maelstrom of superheated matter that reaches temperatures of millions of degrees. This feeding frenzy releases insane amounts of energy across the electromagnetic spectrum. We're talking about a glow brighter than 140 trillion suns combined. Let me repeat that, minus 140 trillion suns. That's so bright, it outshines entire galaxies from billions of light years away. The energy output is so tremendous that if Ton 618 were placed 180 light years from Earth, roughly the distance to some of our nearest star-forming regions, it would appear as bright as our sun in our sky, despite being a black hole. To help you visualize this monster's appetite, imagine this. Ton 618 is estimated to consume matter equivalent to several Earth masses every single day, every day. It's been doing this for billions of years, slowly but relentlessly growing larger and more powerful. Some astronomers believe it formed when the universe was much younger and denser, allowing it to grow to these impossible proportions during an era when galaxies were colliding and merging much more frequently. But here's what really keeps astronomers up at night. We're seeing ton 618 as it was over 10 billion years ago, when the light we're detecting first began its journey to Earth. The universe was only about 3.5 billion years old, then practically an infant by cosmic standards, yet somehow this black hole had already grown to be more massive than most black holes we see in the local universe today. How did it get so big, so fast? This is one of the greatest mysteries in modern astrophysics. Some theories suggest that ton 618 might have formed from the direct collapse of massive gas clouds in the early universe, or perhaps from the merger of multiple smaller supermassive black holes during galactic collisions. But even these scenarios struggle to explain how something could grow so massive so quickly in the cosmic timeline. The existence of ton 618 raises profound questions about the limits of physics and the evolution of the universe itself. Albert Einstein's theory of general relativity predicts that as black holes grow larger, they actually become less dense. Sounds counterintuitive, right? But it's true. The average density inside ton 618's event horizon is actually less than that of water. It's the sheer volume that makes it so incredibly massive. Scientists also wonder about the theoretical upper limits of black hole growth. Could there be black holes even larger than ton 618 lurking in the depths of space? Some models suggest there might be natural limits imposed by the rate at which matter can fall into a black hole and the feedback effects of the energy they release. But ton 618 seems to push right up against these theoretical boundaries. There's also the mind-bending question of what happens to information that falls past the event horizon. With something as massive as ton 618, the information paradox, a fundamental problem in physics about whether information can truly be destroyed, becomes even more complex and fascinating. So next time you look up at the stars, remember, out there in the dark, billions of light years away, there's a cosmic giant with a hunger that never ends. TON 618, the biggest black hole we know of, a true monster in the endless night of the universe, slowly devouring everything in its path and growing ever larger. And here's the real kicker that should give you chills. Ton 618 might not even be the biggest one out there. Our telescopes can only see so far. And there are vast regions of the universe that remain completely unexplored. Somewhere out there, hidden beyond the cosmic horizon, could be black holes even larger, even more massive, waiting to be discovered. Imagine black holes so large they could swallow not just solar systems, but entire clusters of stars. Recent advances in technology like the Event Horizon Telescope and upcoming space missions promise to reveal even more about these cosmic giants. Who knows, in the next decade, we might discover black holes that make ton 618 look small by comparison. The universe has a way of constantly surprising us, and usually, those surprises are bigger and more extreme than we ever imagined. If that blew your mind, hit that like button, because this kind of mind-bending cosmic content takes serious research to bring to you. Subscribe for more of the universe's greatest extremes, from the smallest quantum particles to the largest structures in space. And drop a comment below. What do you think is scarier, knowing that ton 618 exists out there, or the fact that we might never find all the cosmic monsters hiding in the darkness? Let me know what cosmic topic you want me to tackle next. The universe is full of incredible mysteries waiting to be explored.